Well, on previous lesson, we discussed about the data types and we consider some basic operations that we can apply with the variables of the corresponding data types. Now let's discuss about it in more details. When we discuss about the data types, we spoke that the data type is defined by two sets, set of values and set of operations. And these two sets are related. If we consider only the positive integer numbers, we can apply just addition and multiplication. If we consider integer numbers, we can apply addition, multiplication, and subtraction. If we discuss about real numbers, we can apply all the mathematical operations, addition, subtraction, multiplication, and division. And all of these operations are denoted in programming language by corresponding lexemes. Means one or several signs that correspond to their operation. And also some operations can be some operations are represented as the functions in C language. In the lexeme, one or more information elements take part in the operation. And these elements are called operands. Operands or arguments of this operation. And according to the number of operands, operations can be so-called unary. Unary operation means that this operation requires only one operand. And binary. This operation requires two operands. Of course, in our real life, in mathematics, it's more usual to have a deal with binary operation. Binary means with two operands. These operations, I will write the example in just in Visual Studio. This operation, binary operation. Again, binary here means operation with two operands. Can be written as just A plus B. At operation plus have two operands, has two operands, A and B. But sometimes in programming, some operations have only one operand. These operations are called unary. Let's denote as this sign. Let's use this sign just as a sign of a general operation. And operands of this operation, let's denote as operand number 1, operand number 2, operand number 3. Unary operation is written in this or this form, sign of the operation, and after that, the operand. And, sorry, or the operand and the sign of the operation. This form of operation maybe it's not usual. More convenient form is the following: operand number 1, sign of the operation, and operand number 2, like A plus B. But sometimes, even in mathematics, we use unary operation. For example, the operation minus A. Minus A means that the value of A should change its sign. If A is negative, then minus A will be positive. And if A is positive, minus A will be negative. What can we use as operands of the operations? The operands can be constants, named or literal, variables, functions, and expressions. So these are some examples of the expressions. This is a unary expression, this is also unary expression, this is binary expression, and this expression is complex. Complex expression that contains other expressions as their internal parts. Some operations in C, C++ are denoted with the help of the functions. The function operand is written in the following form: name of the function and list of parameters in brackets. List of parameters consists of their information objects, information elements, separated with commas. As the parameters, it may be used constant, variables, other functions, and expressions. So these are two examples of operations that are implemented as a functions. Sinus, x plus k times s, and power. Power means these in power this number in a power this number. So power 2 cos z means 2 in a power cosine z. How to use functions I show you just a little bit later in the end of our lesson. Well, when we combine some operations in more using operations, we can write expressions. In general case, expression in programming language is a sequence of operations, operands, and or parentheses, which defines computing the result of a certain type. I can say that expressions can be primitive, simple, or composed. The partial case of the expression, so-called primitive expression, is just a single constant, single variable, or single function. In this case, just 3 as a single constant can be considered as a primitive expression. Or x, just the name of the variable, primitive expression. The simple expression consists of one operation sign and operands required for this operation. For example, minus x is a simple expression. A plus b is a simple expression, just one operation and the operands. Sinus v is also simple expression, just the operation and the operand. And the last example, a complex expression that consists of other expressions, simple or primitive. Well, what operations we can apply for different types? Of course, we already discussed about some of these operations when we consider integer valued data types. We consider that for integer numbers we can apply addition, subtraction, and multiplication, and also we can apply division for integer numbers. But let's remember that this division will be integer and the result of the division will be integer 2. In this case, 7/2 equals to 3, because both of the operands are integers. Also, we can apply special operation for integer numbers, person sign, that corresponds to the operation of getting the remainder of the division. In this case, 7 person sign 2 equals to 1. We discussed about these operations on a previous lesson. Well, all of these operations are binary. Binary, again, it means that these operations requires two operands. For example, A plus B, C times D, and so on. There are several unary operations that can be applied for integer numbers. The simplest of them are just minus and plus. Minus changes the sign of the operand. Plus does nothing. But it's correct to write just plus C. Let me show you these examples in Visual Studio. Suppose that I declare some integer number A, for example, with value 10. After that, let's output the value of A, and if we apply just minus to A, of course, we will see on the screen minus 10. So pay attention that when we apply minus, A will not change. If I output to the screen A still be 10. Minus A will be minus 10. So the value of A is not changed here. Also, I can apply operation plus. Yes, it does nothing, but it will be correct from the point of view of compiler. If I compile this program, when I compile this program will be correct. Compiler tells us, okay, no mistakes. But of course, plus A does nothing. Well, more complex unary operations. So non-traditional operations that we have no such operations in mathematics are plus plus and minus minus. First of them adds 1 to the operand, and the second subtracts 1 from the operand. Let me show you examples. Well, A++. Operation plus plus, so it's not 2 pluses, but 1 operation plus plus. 1 operation that is denoted with 2 pluses. A++ adds 1 to the variable A. And after the operation, A will be 11. And if I output to the screen the value of A before and after operation plus plus, I will see 10 and 11. And in this case, when this operation is applied to standalone variable, it doesn't matter where I put plus plus. I can write plus plus A or A plus plus. The result will be the same. I will see 10 and 11. And the same I can say for minus minus. Minus minus subtracts 1. In this case, we will have 10 and 9. And also I can write minus minus a, and I will see 10 and 9. But there is one feature. One feature of these operations. Let me write the operations like this. Let me write a++ inside the output statement. The result that we will see on the screen will be 10, 10, and 11. So any operation has a result. For example, what is the result of a plus b? We just compute a plus b, and this new number will be the result of the operation. And in this case, a and b are not changed. But when I write a++, the result of this operation is the old value of a. But after the operation, a will be changed. A will be increased in by 1. But the result will be old value of a. And we will see on the screen 10, 10, and 11. And when I write plus plus a, the result of this operation will be new value of a. The variable a will be changed in both cases, but the result of these operations are different. In the first case, the result is the old value of a. In the second case, the result is a new value of a. So when I write here not a++, but plus plus a, we will see on the screen 10, 11, 11. Plus plus changes the value of a and returns it as a result. But I just mentioned this feature of operations plus plus, and the same I can say for minus minus also. But if you will use these operations, as their standalone operations, like this, it will be no difference where you write plus plus or minus minus, before or after the operand. But if you will write these plus plus or minus minus inside a complex operation, the result can be maybe not so simple as on the first view. Okay, you can look to these expressions. You can look on these examples here in my presentation. I can use plus plus inside some complex computational operation. In this case, the value of C will be 6, but the value of A will be 8, because the old value of C participates in this operation. But if I write here plus plus before, then new value of C take place in this operation, and the new value of A will be 9. Well, the next group of operations are so-called shift operations. Let me skip it. We come back to these operations later if we'll have time, because shift operations is not used very often in programming, and also in our lessons, I think we will never use it. Let me skip these slides and let's discuss about more useful operations. So logical operation we also skip. Well, let's discuss about more useful operations that are implemented as a functions. There are a lot of operations that we use in mathematics. And these operations are implemented in an additional module, math.h. To use it, we should write at the beginning of the program, include math.h. Let me do it. So after include IOStream, you can write include math.h. You can write it with point or without point. It's better to write it with point. So because without point, it's the name of this module is C math, but let's use the style C language style math.h. This module contains a lot of useful mathematical operations, and for integer numbers, related for integer numbers, maybe the most useful operation is abs, the absolute value of the number. What is the absolute value or module? The result will be the same if this number is positive, and result will be minus x if the number is negative. Let me show you the example. So, for example, a is 10, and let's output to the screen absolute value. Abs a. If a is 10, then result will be 10. If a is negative 10, then result will be 10. So abs means module, absolute value. All the operations, it has priority. And for traditional operations like addition, subtraction, multiplication, I think you guess that priority of multiplication is greater than the priority of addition. And if, for example, I write such expression, let me write such expression, 2 plus 2 times 2. What will be the result on this expression? What? 8. Wrong. 2 plus 2 times 2. What will be the result? 6, of course, because the priority of multiplication is greater than the priority of addition. So this operation will be carried out first. and only after that addition will be carried out. And in the case when the priority of the operation is the same, these operations are carried out from right to left. Sorry, from left, of course, from left to right, from left to right. And if I write such expression, for example, 6 over 2 times 3, what will be the result? The result will be 9. Not the division first, but the operations will be carried out from left to right. First will be carried out division, and after that, the result of this operation take part as the first operand of the second operation, and the result will be 9. To change the order of operations, we can use a parenthesis. In this case, when we enclosed some part of the expression in brackets, in parentheses, it changes the priorities. And in this case, first will be this operation, and the result will be 1. Well, the priorities of the operations are written here, but it includes also shift, bitwise operation. We consider it later. Well, and also just a few words about the type of the expression, because the parameters, the operands, can be of different types. Of course, in your programs, we use just int for integer values is the most useful type, but imagine that we use two values, for example, int a and short int b. And after that, I apply the operation a plus b. Well, and the question is, what will be the type of the operation? Because a and b both are variables of integer types, but a is int and b is a short int. Or even I can write here long int. A long int, b is a short int. But what will be a plus b? Of course, you can guess that the result will be minus 8 in this expression. But what will be the type of the result? Long int or short int? Yes, the result will be long int, because the type of the result corresponds to the more wide type, more powerful type of the operands. And if I write here, for example, int and long int, the result also will be long int, because long is a more powerful type. If I write here short int and int, the result will be int. Okay. more complex question. Let's consider short int a, but the expression a plus 2. What will be the result? In this case, sorry, of course, the value of the result will be -9. Oh, sorry, minus 8. The value of the result is not changed. But what will be the type of the result? No, int, because every constant, literal constant, is considered by compiler as int. Well, of course, it's maybe just some particular features of these integer numbers. And if you will use the only int in your programs, it's not a problem to guess what will be the result. The result will be int in any cases. But it's just, I want just to stress that when we consider the operation, we should think not only about the value of the result, but also about the type of the result. Because in some cases, it can be situation of so-called overflow, when the result, when maybe the value of the result will be larger than the largest value that can be expressed by this type. Well, so the simple rule that the type of the result corresponds to the type of the longer operand. Okay, there are some operations with real data types. We consider two real data types, float and double. I said that these two data types differs in the range of representation of real numbers, and also these two data types differs in precision. Double has twice more numbers after the decimal point. Its precision, double is 2 times accurate in comparison with the float. For the float and double, we can apply all of the usual operands, operations, addition, subtraction, multiplication, division, and the result of the division will be real division. Also, we can apply plus plus and minus minus for the real numbers. Let me show you the example that a, it can be, for example, double a minus 10.1 minus 10.2, and I can apply a plus plus. In this case, the result will be minus 9.2. So we can apply plus plus and minus minus, both for integer and real valued data type. Minus minus subtracts 1. Okay. And maybe one of the important information for you, that a lot of mathematical operations are implemented in a module math.h. Here you may see the table of this operation. Of course, it's even just not complete. It's not complete table, but in this table you may find maybe the most useful operations that can be applied. all of the trigonometric functions like arc cos, arc sine, and so on. Some special functions, for example, not just arctangent, but special implementation of this arctangent. The name of the function is artan2 with two parameters, x and y, and it corresponds to arctangent y over x. Two operations of rounding, sail and floor. Sail, it rounds up, and floor, it rounds down. F ups returns the absolute value. Exp returns the exponent e power x. Cos returns cosine x. Some special function, the hyperbolic cosine. I think we will consider this function on mathematics later. Logarithm, natural logarithm of x, log 10, logarithm with radix 10. The function max that returns the maximum value between a and b. Mean that returns the minimum between a and b. The function power. Power has two parameters, x and y, and the result is x in the power y. Power 10, that has a result 10 raised in power p. Sinus, hyperbolic sinus, very important function, square root. If you want to compute a square root of x, you can call the function sqrt. Tangent, hyperbolic tangent, and so on. A lot of mathematical functions. How to use it? First, you should write include math point h, and after that you can use these functions. For example, let's consider a let it be a 10 and sqrt a, square root of a. What is the value of square root of a? Of course, I ask about not precise value, but can it be 1? No, but what is the value of square root of 10? Okay, what is the value of square root of 9? Who can give me the answer? What? 3, of course. 3, boss. Yes. Square root of 9 is 3. But in this case, square root of 10, it should be the value that little bit greater than 3. 3 point something, 3.1, 3.2. I don't know. 3.33. No, 3.1, 3.16. Of course, nobody knows this value, but I can guess that this value, it should be a little bit closer, a little bit greater than 3. And in this case, if I write square root of 8, this value should be a little bit smaller than 3. It should be 2.88, something like this. 2.82. Well, square root, very important function. Also, very important function is are sinus and cosine. For example, if a is 0, what is the sinus of 0? Sinus 0. Sinus 0. Sinus 0. No. Any other ideas? Sinus 0. Sinus 0 is 0. Cosine 0 is 1. Cos 0 is 1. But sine 0, sine 0 is 0. Sinus 0 is 0. And one of the previous lesson we just mentioned that there are some important numbers in mathematics, and one of these numbers is pi, 3.1415. What is the value of sinus pi? Do you have any ideas what is the value of sinus pi? This number, of course, it's not pi, because pi is a number with endless fractional part, but it's close to pi. Sinus pi is also 0. But we will see the result that is not 0. But this result will be close to 0. What is this number? Is 9.2 multiply 10 times 10 power minus 5. 10 power minus 5. And the result will be close to 0. Maybe the last example that I want to show you. Suppose that I have two values a and b, and the function power a, b. What I will see as a result? The meaning of the function power is power ab means a power b. Two power 3. 9 is wrong. A b power. Yes, ab means first number raised in the power of the second number. Power ab means a power b. The result will be 8. Also, I can compute here not only integer powers, but any real number. For example, a power 1 over b with some result, or even 1 over a power 1 over b. I can use any real numbers as the parameters of the function power. Well, there are two more examples of rounding function. sale and floor. Sale rounds up. It returns the integer number that is more close to this parameter, but greater. For example, sale 0.1 equals to 1. Sale 2.5 equals to 3. Sale 5.8 equals to 6, but sale minus 5.8 equals to minus 5, because integer that is close and greater. And the same I can say about floor. Floor returns the closest integer number that is less or equal. Floor 0.1, 0. Floor 2.5, 2. Floor 5.8, 5. But if we consider negative numbers, for example, floor minus 5.8 equals to minus 6. The result must be less than or equals. In a C language, there is no function that rounding to nearest integer number, because here, for example, when we apply floor 5.8, 5 is not the nearest number. The nearest number is 6, but floor returns that the number that is less. To return the nearest number, we can apply the function floor x plus 0.5. Indeed, if x is smaller than 0.5, that we get the integer part of x. If x is greater than 0.5, the result is equal to integer part of x plus 1. For example, let me show you floor a plus 0.5. For example, a equals to 0.1. The closest integer number to 0.1 is 0, and the result will be 0. If I consider, for example, 0.9 and apply floor a plus 0.5, the closest number to a is 1, and the result will be 1. Well, finally, some useful constants are defined in the module math.h. These constants corresponds to pi, and the constant is denoted m pi. The constant that corresponds to e and denote me, but I cannot use just m pi in my program. If I write m pi, compiler outputs mistake. To use this constant as number pi, I should write here a magic line, define use math defines. If I write define use math defines before math.h, after that, the constant m pi will be accessible. And if I output now the value of a to the screen, I will see that A equals to pi, 3.14, 15, 9, and so on. I can use also the constant ME. And now we will see the value of the number E, 2.71828, and so on. Okay, also, you should remember that we have several data types, several real data types. And also, if the expression contains two or more variables with different data types, in this case, the result will have the type that corresponds to more powerful type of their arguments. And in the case when you write a constant, this constant is considered to be double. So if you write here float A, for example, equals to 1.1, in this case, the value of A, variable A, will have a data type float, but the constant 1.1 will be double. If you move your mouse here, you will see the hint that is output by Visual Studio that 1.1 is a double. You should always remember it, that you will have two different data types, and double is more powerful. Well, we have 15 minutes, and also we have a time to consider one more operations. I switch to another presentation, and we discuss about comparison operations. The comparison operations, as a comparison operation, so we can use usual less than, greater than, less than or equal, greater than or equal, equal, and not equal. We can apply these operations for different data types. Integer, real data types, so on. What is the result of the comparison? The result of the comparison is so-called logical or Boolean. Logical result can have just two possible states, true or false. As a true, we can see the value 1 is considered as true, and the value 0 is considered as false. So if the result of some comparison is false, the result of this operation will be 0. So please remember, 0 is a false, 1 is true. And we can apply this comparison for any numbers of any data types. Let's consider some example. Let's me declare two variables, A and B. For example, A is 1, B is -1. Okay. And let's output to the screen the result of the comparison A greater than B. A is 1, B is -1. What is the result? A greater than B. True. So we will see on the screen 1. The result is true. A is smaller than B. False. Result is 0. For logical variables, for logical values in C++, there is a special type, special data type that's called Boolean, bool. Why we use bool or Boolean? We use this notation in order to English mathematician George Boole, who invented this, who suggests so-called Boolean algebra, the algebra that operates only with true and falses, with zeros and ones. If you type in Google George Boole, you can read about this mathematician, and in order to this mathematician, it introduced so-called Boolean algebra, the algebra that operates only with zeros and ones. And in order to this person, this type is called Boolean. You can read about it in Wikipedia. But let's remember that Boolean type, it corresponds just to the type that have only 2 possible values, true and false. Bool result equals to A smaller than B. So I can assign to this value result, the result of the comparison, A smaller than B, because comparison returns as a result only true or false. And I can output the value of the result to the screen. A smaller than B, the result is false. So we will see on the screen 0. But just as a remark that we can use this constant true and false. You can see that true and false are reserved words. I can use it only in predefined sense. In this case, the result will be true 1. But okay, but I reassign the result. Yes, here the result is true, but I change its value. The result, of course, the result of comparison is false, but after that, I write another value to the result, true. And in this case, we will see on the screen 1, true. What? It's not a hacker's method. Just I change the value of the variable, and if A greater than B, the result is true. Result is 1, true. But I can change the value of the result, for example, to false. And we will see on the screen false, 0. Result is 0. Well, also there are operations that compares two numbers, equal, not equal. A equal B. What is this? What will be the result? A equals to B. False, of course, because A is the 1, B is -1. The result is false. Not equals A, not equals to B. True, because A is 1, B is -1. Different values. True, but if I assign A and B 1 and check A not equals to B, the result will be false. Result will be false. Yes, if it's equal, if I compare A equals to B, the result will be true. Result is 1, true. So please remember, true is 1, false is 0. To store these results, I can use special variables of data type bool, logical data type. So 0 is false, 1 is true. So A smaller than B is 1, A equals to B. So all of these are examples that I show on the slide. I show you in Visual Studio. Well, we have just 5 minutes to the end of the lesson, and we continue our next lesson from this point. We discuss about logical operations and logical expressions, and after that we discuss about maybe assignment operation in details. We consider assignment operation. Well, let me stop sharing my screen and stop recording. Do you have any questions about our lesson? I will send you the video file, not the video file, but the link to the video today, later. Next week, we continue from this point.